the measurement of internal resistance of a cell by potentiometer. We know that what is internal resistance of the cell. Internal resistance na என்னன்னு நமக்கு தெரியும். ஒரு பேட்டரி இருக்குனா அதுக்குள்ள இருக்கிற ரெசிஸ்டன்ஸ் தான் என்னது? Internal resistance. So now we are going to calculate the internal resistance of a cell by using the potentiometer. அப்ப potentiometer use பண்ணி internal resistance calculate பண்ண போறோம். So again we can take that circuit. See, this is a circuit is connected with the battery, key and CD. So that's called primary circuit. See the secondary circuit. Secondary circuit that E is the EMF of the battery and it is connected with the external resistance R. K2 is the key. G is a galvanometer, HR resistance and it is connected to the metal jacket. Initially K2 is open, only key K1 is closed. So what will happen? The current flow in a primary circuit and the current flow through only this battery. So it is not flowing through the external resistance, right? But it's only flowing through this circuit. So you can calculate the balancing length is equal to the EMF of this battery. Okay, so current only flow this circuit. After connected the external resistance by using the key K2. So when key is connected to the circuit, so the external resistance is included into that circuit. So what will happen? That battery current flow in this circuit through this battery and the resistance. Okay, so now we can balance by using the metal jacket we can calculate the balancing length. So the first equation, initially that balancing length L1 is equal to the battery. So balancing initial length L1 is equal to the battery because we are not included the resistance R. Now when after included the next one, that is resistance R. So what will happen? According to the Ohm's law, V equal to IR or I equal to V by R. So that epsilon is psi is the potential divided by resistance R plus R, where capital R is the external resistance, small r is the internal resistance. Here two resistors are connected in series. That is why we are adding the two resistance R plus R. I equal to V by R. So I equal to psi by R plus R. Okay. So next one is V equal to IR. So I value this one E by R plus R. So V equal to IR. So V equal to I, instead of I we are writing this equation into R. So this is the potential drop across the resistance. So here we calculated the second balancing length after included the R by using the K2 key. So this is L2. Now we can divide the two value L1 by L2. We can compare, we can divide the two equation L1 by L2. So what will happen? L1 by L2 means that epsilon cancel each other. Remaining we will get the value of R plus R divided by R. So R by R is cancelled. So 1 plus R by R, L plus L1 by L2. R we can write, we can take that plus 1 into other side, it will minus, it will become minus. So that is minus 1. So R equal to capital R into L1 by L2 minus 1. So now we can multiply that L2 with 1. You will get R equal to capital R L1 minus L2 divided by L2. So where small r is the internal resistance, capital R is the known resistance we are included in this circuit, and L1 L2 is we calculated. So substituting all these values you can calculate the internal resistance of the cell, right? So this is the method of finding the internal resistance of the cell by using the potentiometer. So next we are going to see the last topic, heating effect of electric current. So heating effect of electric current. So heating effect of electric current. Why that heat is produced? Because when the current is flowing through the conductor has the resistance. The resistance converts the electrical energy into heat energy. When current flows through a resistor, some of the electrical energy delivered to the resistors is converted into heat energy and it is dissipated. So when the current is flowing through the conductor, it has the resistance. Because of that resistance, that current is losses in the form of heat energy. அப்போ ஒரு கண்டக்டருக்கு கண்டக்டர் வழியா கரண்ட் ஃப்ளோ ஆகுது அப்படின்னா அதுல ரெசிஸ்டன்ஸ் இருக்கிறதுனால அந்த ரெசிஸ்டன்ஸ் என்ன பண்ணும் அப்படின்னா இட் கன்வெர்ட்ஸ் தட் எலக்ட்ரிக் கரண்ட் இன்டு ஹீட் எனர்ஜி. ஹீட் எனர்ஜி என்ன ஆகுது? டிசிபேட்டட் இன்டு தட் ஏர். அப்போ அந்த ஏர்ல அந்த ஹீட் எனர்ஜி என்ன ஆகுது? வேஸ்டா போயிடுது. ஸோ வி கன்வெர்ட் தட் heat energy into so electrical energy into heat energy. At the same time, the heating effect of current is also known as the Joule's heating effect. So this is called Joule's heating effect. So we are producing the thermal energy by using the current. So current flow ஆகிறதுனால heat வருது. Heat எதுன்னு சொல்லுவோம் அப்படின்னா thermal energy. So we can convert the thermal energy into heat energy. That is called thermoelectric effect. So we can convert the thermal energy into electrical energy. That is called thermoelectric effect. That is called thermoelectric effect. So this is called the passing of electric current, how the heat energy is produced. So when that this battery is connected to the nichrome wire, current is flow from the battery to the conductor. The conductor has the resistance. So in that resistance, it converts that energy, heat energy into, so electrical energy into heat energy. Right, when the current flows through the conductor, it converts the heat electrical energy into heat energy. Right. So next we are going to see the Joule's law of heating effect. So Joule's law of heating effect. Joule's law. So we know that power P equal to VIT. So here the power equal to W, or we can write W equal to VIT. Or W is the work amount of work done. Here amount of work done is the heat energy. That's why we are writing H is equal to VIT. We can write H is equal to VIT. I equal to IR according to the Ohm's law. So H is equal to I square RT. H is equal to I square RT, where H is the heat energy, I is the flow of current, R is the resistance of the wire, where T is the time period. So in this relation, experimentally verified by Joule and is known as Joule's law of heating. The heat is in an electrical circuit due to flow of current varies. That heat energy is varies. It is directly proportional to the square of the current and directly proportional to the resistance of the circuit, and it is directly proportional to the time of flow. So this is called Joule's law. So Joule's law equal to H is equal to I square RT. Right? So it's called Joule's law. Then application of Joule's law. So what are the applications of Joule's law? So Joule's law's application is electric heaters, iron box, and electric fuses, electric furnace, electric lamp. These are all the uses of Joule's law. Okay. In that Joule's law, the common example of electric iron, electric toaster, electric oven, electric kettle, and electric heater. These are all the example for the Joule's law of heating. So in that one, we are going to see the first example, an electric bulb. It consists of filament. This filament is made up of tungsten. So when the current is flowing through that filament, it will produce the light. It will become hot and emits the light. So through the current, melting point of tungsten is 3380 degrees centigrade. So when the current is flowing through the tungsten filament, it will produce a large amount of heat energy. Only 5% of current is converted into light energy. Remaining 95% is used in that heat energy. So nitrogen and argon gas is filled inside the gas. Okay. So iron box. That iron box is another one example. So it's a mica sheet, and next one is the metal block. Between that, we are placing the conductor. When the current flowing through that conductor, it will produce the heat energy. But mica is an insulator. It does not conduct that energy. That's why only the bottom of the iron box only gets heated. So it does not conduct the heat energy to the handle. So this is the use of Joule's law. So it prevents the current from entering into the metal, and thus protects the user from the getting an electric shock. So that's why we are using the mica. So the state of application of heating effect of electric current. So the applications of heating effect current is electric bulb, electric iron, fuse wire, electric furnace. In industries, we are using the soldering, welding, cutting, drilling. So these are all the example. In surgery, for cutting tissues with a fine heated platinum wire, a technique is more efficient than the knife. So operation purpose also we are using that this one. Okay. So next one we are going to see that thermoelectric effect. Thermoelectric effect means already I told you that thermal energy is converted into electrical energy. So it is a reverse effect of heating effect. So in heating effect we convert that heat energy, electrical energy into heat energy. That heat energy also converted into electrical energy. That is called thermoelectric effect. So it has the three effects: Seebeck effect, Peltier effect, and Thomson effect. So in that first we are going to see the Seebeck effect. So Seebeck effect, see the Seebeck effect. So when that two dissimilar metals are placed in a two different temperature, that EMF is produced. That is called Seebeck effect. So when two dissimilar metals means two different metals. So two different metals are placed in a two different temperatures. That means one is a hot temperature, another is a cold. Cold hot means it is not mentioned 0 and 100 degree. Two different temperatures, that may be a 30 60, 40 70, 20 80, like that. So it is not a meaning that from 0 to 100 like that. It's not. Two different temperature when thermocouple means two different metals placed in a two different temperature, that current is produced. So dissimilar metals connected, thermoelectric current is produced. That effect is called Seebeck effect. So that effect is called the Seebeck effect. So it's not responding. So wait for 5 minutes to responding the PowerPoint presentation. So it's called the Seebeck effect. So the application of Seebeck effect is used in the thermoelectric generators. So Seebeck generators and thermoelectric generators are used in the power plant. So power plant la நம்ம யூஸ் பண்றோம். Power plant la boilers la irundhu நிறைய heat energy வெளியில வரும். அப்படி வெளியில வர heat energy we can convert that heat energy into electrical energy. So the effect is utilized in the automobiles, automotive thermoelectric generators for increasing the fuel efficiency. So the automobile la pathina engine la irundhu vara heat energy we can convert that into electrical energy. That electrical energy is used in the automobiles. Next, Seebeck effect is used in the thermocouples and thermopiles to measure the temperature difference between the two objects. So using the Seebeck effect we can find out the thermocouples and thermopiles used the temperature difference. So temperature difference enna irukku. Okay, so now you can see that Seebeck effect. So in 1821 Seebeck found that current flows in a circuit consisting of two dissimilar metals. That means two different metals. When one junction is heated, that other junction is kept cold. So two dissimilar metals connected to form two junction is called thermocouple. That is called thermocouple. When one junction a thermocouple copper ion, you can take that's placed in a cold junction, another one is hot junction. So what happened? That current is flowing in that circuit. That's called Seebeck effect. Here we convert that thermoelectric, that is heat is converted into electric current. A cold junction current flow from that iron to copper. So when you are inverted, that when you reverse that to temperature, the current is flowing in the opposite direction. The EMF produced is called thermo EMF. That current is called thermoelectric current. Now Peltier effect. Peltier effect is the reverse method of Seebeck effect. So Peltier discovers that when electric current is passing through the circuit, it consisting of two dissimilar metals, heat is evolved in one junction and heat is absorbed in the other junction. So see here the thermocouple. Now we connected the battery. Initially we are placing the two different temperatures, current is produced. Now we are supplying that current. What happened in junction 1 and 2? One junction is heat is liberated, that is hot junction. One junction is heat is absorbed, that is called cold junction. So when current is flow, one is become a hot junction, another one become a cold junction. So that is called Peltier effect. It is converse of Seebeck effect. ஸோ அதெல்லாம் அப்படியே தலைகளாக போட்டோம் அப்படின்னா Peltier effect. Seebeck effect அப்படியே ரிவர்ஸாக பார்த்தீங்கன்னா Seebeck effect. Now Thomson effect. Thomson effect. In 1851, Thomas suggested that when current flow through a unequally heated conductor, heat is absorbed or evolved throughout body of the conductor. Here, that in that two method we consider only point, but here we have to consider the throughout metal of the body. Now we can consider the T1 and T2 are the 2 points. So unequally heated conductor, so heat is absorbed throughout the body of the conductor, and when the current is flowing through the conductor, heat is liberated throughout the body. So here that heat is absorbed and heat is evolved throughout the body of the conductor is called Thomson effect. So these are all the example for the Thomson effect. Silver nitrate, zinc, cadmium and antimony. Negative Thomson effect. When current is flowing in an unequally heated conductor, so from lower temperature to higher temperature, current is flow from T2 to T1, heat is liberated. So for iron metal, when you are using that iron metal, current is flow from the higher to lower, heat is absorbed throughout the body. So that type of effect is called negative Thomson effect. Example of that materials are bismuth, nickel, platinum, copper and mercury. So this is negative Thomson effect. Last one is nil Thomson effect. So when that temperature unequally heated conductor, current is flows from lower temperature to higher temperature. So what will happen? That heat is not evolved or absorbed. So that is called nil Thomson effect. Heat வெளியில வராது, absorb ஆகாது. So it has no cold junction or heat junction. Example for that only lead, Pb, lead. Lead has the nil Thomson effect. 1 mark la கேட்கலாம். Okay. So last one is the thermopile. It's a example for Seebeck effect. So thermopile is a device used to detect the thermal radiation. It's based on the principle of Seebeck effect. So already நம்ம பார்த்துட்டோம். So that is the uses for Seebeck effect. So in these 3 effect, definitely any one question will ask in the 3 mark question or 2 mark question, even in a 5 mark question. Okay. So up to this the lesson.